Okay. I've done that, so we can move on. So, like I was saying, last time we dealt with arithmetic mean, mode, median, and we were able to look at group data. In that group data, we'll be able to find mean, mode using formula. And the last time we met, which was the second class, we were able to look at calculation of mean using actual mean. We did that. The last class was on that variance and standard deviation. So for today, we'll start with calculation of variance and standard deviation. Standard deviation using assumed mean. Assumed mean approach. Can you see the board?
Yes,
Hello?
sir.
Good.
Yes, I can see the board.
Good. Calculation of variance and standard deviation using assumed mean. So that will help us to conclude what we started on this part. Without wasting much of our time, in calculating variance and standard deviation using assumed mean, that means we're given set of numbers and we're expected to calculate mean. But when it comes to what is it called? When it comes to set of numbers, we may ignore. But let's start with frequency distribution and group distribution to calculate that as fast as we can. The last time we met, there was a question, but I know I don't need to dwell on that. Let me just give you. There's the first question we're going to talk about today. Number one, here is X, here is F, and here is 20, here is 25, here is 30, here is 35, here is 40, and here is 45. We have the frequency as 3, 5, 1, 1, 1, 2, and then 3. So the question says, find first in mean. So we should find first in mean. Then the second one, okay, we might not even bother ourselves, okay, but let's just, already we know mean. We don't need mean for that one. So we just need to use assumed mean to find variance and standard deviation. Let's just go straight. Variance alone and standard deviation. Just variance and standard deviation. Remember, we're using assumed mean approach. Is it clear?
Yes, sir.
Have you copied this? This is question 1. This is a frequency distribution. We're going to find variance and standard deviation using assumed mean approach in getting this. And I'm going to get the table numbers. You're welcome.
Sir, under 30 and 35, for the frequency, is it the number? Is it 1?
1, 1, yes, 1, 1. Yes, 1, 1, yes. 40 is 2, and that one is 3. Are you done? With the question say find variance and standard deviation. Remember, we are using assumed mean approach. Can I clean the board?
Yes, sir, you can, sir.
Good. Now, solution, as we know before. We'll go this way, like this. One column, another one. One more. This column, these are X, 40, 45. Our frequency hasn't changed. It's still 3, 5, 1, another one, then 2, then 3. So haven't done that. From 20 to 45, we'll decide to assume anyone we like. This is our variable X. We assume anyone we like. But like I told us, you can assume anything, but the answer will still be the same. Let me assume 40. In examination, sometimes they will specifically tell you what to assume. They will tell you our assuming is this a value. Or whereby the question did not tell you anything, you are at liberty to assume 20, 25, 40, 35, 45, anyone you like. But I've now decided to assume a 40. My assumption now is 40. So because I have taken 40 as my assumption, I'll find deviation. D. Remember, deviation, that is X minus capital A. Remember that we have two types of deviation. We have deviation from actual mean, and we have deviation from assumed mean. The last one we did was deviation from the real mean, but this one is the assumed mean. And our assumed mean is 40. Our X, which is the variable, is from 20 to 45. So I'm going to take the deviation. 20 is the first X. 20 minus 40 will give me minus 20. 25 minus 40 will give me minus 15. 30 minus 40 will give me minus 10. 35 minus 40 will give me minus 5. 40 minus 40, it will give me 0. 45 minus 40 will give me 5. Is that column clear?
Very clear, sir.
Very good. The next column is to take deviation square. D raised to power 2, deviation square. We need a deviation. We need a deviation square before we use the frequency to multiply. Squaring 220 will give us 400. 15, 15 will give us 225, I believe. 10 square will give us 100. 5 square will give us 25. 0 square will be 0. 5 square will be 25. I hope that is also settled. We're now going to have F times D. We're also going to have F times D squared. The next column is F times D. The last column is FD squared. It is the D that has raised to power 2. We're going to get F times D squared. We're going to have F times D. So FD is the next column. The last column is F. D. That D alone is raised to power 2. Is it clear?
Yes, sir.
Good. I'm trying to do something. It's not. Maybe he has reached something there. But let's multiply. F is 351123 multiplied by T. That will give us minus 60. 5 times minus 15 will give us minus 75. 1 times minus 10 will give us minus 10. Then 1 times minus 5 will give us minus 5. 2 times 0 will give us 0. 3 times 5 will give us 15. So that column has gone. We're now using the F to multiply everything about D square. D square. So 3 times 400 will be 1,200. 5 times 225 will give me 1125. Will give me 100. 1 times 25 will give me 25. 2 times 0, we all know is 0. And 3 times 15, 3 times 15 will give us 75. Is that 75? No. 3 times 15. 45, Abi? 45, Abi? Okay, yes, 3 times 25. Yes, 75. Good. That there. We now need to get this total. This total, this one is already 15. That's the total for that one. Minus 60 minus this one should give us. That one is minus 135. Minus 60 plus minus 75 plus minus 10 plus minus 5 plus 15. Automatically, minus 10 minus 5 is already minus 15 plus 15, that is 0. So 60 minus 60 plus minus 75 will give us minus 135. So that column is minus 135. And this one, if you add very well, that one should give us 25, 25. Any questions?
Sir, I have a question, sir.
Please
on
go ahead.
column D raised to power 2.
Good.
Minus 20 raised to
Yes.
power 2. I was expecting we'll have a minus 400.
Okay. What did you press your calculator?
Yes, sir.
And it gave you minus 400.
Yes, sir.
Okay, that means the fault is yours. This is how to do it. You open bracket, minus 20, close the bracket, raise to power 2. It will give you 400. Can you do that? Because minus 20 simply means minus 20 times minus 20. And in mathematics, you know that minus times minus is plus. Abi?
Yes, sir. Please, sir,
So
come again.
no,
The open bracket. You said minus 20.
What it simply means, square means that minus 20 we are saying 2 times. It means minus 20 times minus 20. And that should be 400. Check
All right.
out.
Thank you,
So,
sir.
but if you want to use your calculator to run it, always put bracket. Bracket open, you put minus 20, you close the bracket, you raise to power 2. It now gives you 400 straight away. Is it clear?
Yes, sir. Thank you, sir.
So, is this table okay? Copy. All we need now is the frequency table, which is 15. the FD column, which is minus 135. Then FD square is 25, 25. That is how to find variance using assuming approach. Sometimes, like I said, they can give you the assuming yourself, or you decide to choose among the variables which one should be the assumed mean. Is it clear?
Yes,
Go ahead.
you said that FD is what do you call FD, sir? FD column.
And FD column is minus 135. Minus 135.
It should be 145, sir.
You don't know maths too much with that. Okay, let's see it together. Minus 60. Abi?
Okay, I've seen it, sorry.
Because like I told you, I'm even teaching you from my textbook written by me since 1999. So I don't think there's an error there. Okay. So any other questions? Did you see my test? Okay. Did you attend the first class that day?
Myself, no. No.
Okay.
No, I didn't.
Okay. For information purpose, the person teaching you, his name is Author St. Vincent. He's an author of mathematics textbooks and accounting textbooks.
I know you from finance.
That's good. But my book is still in Unilag Bookshop. Teach Yourself Mathematics. Thank you. What's your name again?
My name is Robert Aditunji.
Oh, thank you. Okay. Can I clean the board now?
Yes, sir, you can.
Okay. So the next thing with this table that you have, the next thing is for us to really calculate the problem. Variance is equal to summation of FD squared over summation of F over summation all raised to the power of 2. This is our formula. When it comes to assume mean, like I told them the last time, when it comes to assume mean approach, our variance formula is lengthy. When it comes to the actual mean, this first one, this one alone will be our formula. We will not need the other one. If it is actual mean, it is this alone that will be our formula. When it is assumed mean, this will be like this. So in a simple language, you have the first one is 225 over 15 minus. That means that that line I draw on top as if it's minus. This is the real minus, so do not make mistake. You have minus 135 all over 15. Everything raised to the power of 2. This is our formula. So 25 over 15 minus 135 over 15 raised to power 2. That means everything in that bracket, I'm going to divide it and raise it to power 2. I'll divide the first one, then the difference will be our variance. Have you written it?
Yes, I copied, sir.
Good. And the other students, have you taken it also? The female student, I believe. Have you taken it?
Yes, sir. Yes, sir.
Huh? You want to? You want to do what? Okay. The variance will now be 25 divided by 15 will give us 168. Good. Then the other one, if you square what is inside, you divide by, that should be 9. And 9 square, I believe, is 81. And the difference, if you saw what we did before with, what is it called? With actual mean, what we got at that time was actually 87.33. You can reason that same question, just to confirm that whichever one method you use, we are bound to get the same answer. And the standard deviation, which we know is the square root of variance, square root of all that formula. And that's the square root of 87.33. And the result of the square root of that should be 9.35. So this is the answer for standard deviation. Standard deviation is the variance, the square root of variance to get standard deviation. If you square standard deviation, you get variance. You find the square root of variance, you get standard deviation. So that is just the solution to that question. We are done with that. Any questions? Welcome back. Can I claim? Mr.
Yes.
Jawood, I just rejoined. Can I claim? Okay. That is first question. The second question, which does not involve too much stress, but let's just also look at it. The question says, find the variance of 1, 2, 3, 4, 5. Are you there? Find the variance and standard deviation. Question 2 for today. Find the variance and standard deviation given the following set of numbers. Given the following set of numbers. 1, 2, 3, 4, 5. Using an assumed mean approach. Using an assumed mean approach. So it's still the same thing, but this one is just single set of number where there is no frequency. So this is our X. All we need to do here is to find deviation. Find deviation from assuming. One, 2, 3, 4, and 5. So our deviation our deviation, x minus a. So let me assume that my assuming is 2. Like I said, you can assume any variable, whether the question, as far as the question did not give you a particular value. So our deviation as usual will be 1 minus 2, that will be minus 1. 2 minus 2, that will be 0. 3 minus 2, 1. This one, 2, and this one, 3. So in this case, because there's no frequency, we just square everything, square this, square this, square this.
Sorry, excuse me.
Yeah?
How did you, what is
Go
the
ahead.
value of
Value of
A?
A is 2. You can see me, I've written A attached to that 2, showing that the 2 is assuming, yes.
Okay, is it arbitrary?
No, anyway, you can assume anything you like. You can go home now and do that research. You can assume 1, 2, 3, 4, 5, you get the same answer. But if the question in examination has specifically said, assume 4, you obey them. But if there's no specification, you assume any variable you like.
All right, thank you.
Now, we add all this together. The total here is 15. The total here is 5. 5. So, because there's no frequency like the other one, so our D total is 5. Our D square total is 15. We still follow that our formula as usual. Our variance is equal to summation of D square over N minus summation of D all over N all raised to power 2. That's how this one will be. Summation of D all over N, summation of D squared. So this one, because there's no frequency in this one, that's why you don't see F. So 15 over 5 minus 5 over 5 all squared. The result of this one, 15 over 5 is 3 minus 1 is 1. Truly, our variance is 2 whole number. So you can see, and if we should go this corner, our standard deviation will be equal to the square root of variance to be equal to the square root of 2, and the square root of 2 is 1.141. 1.141. So you can see in this second question, we have succeeded in finding variance of set of numbers that does not have frequency, variance, the formula, standard deviation, and that one also gone. I would any questions?
The square root of 2 is 1.414, sir.
Yes, for 1.415. Good.
Yes, sir, not 141.
Yes, you are correct. 414. Good. You're doing well. 414. So with that, we can say that one is gone. We have seen a set of numbers. We have seen frequency. We want to see the last one of these that will also lead us to interquartile range and semi-interquartile range. We'll look at also variance. We'll look at mean also, in case some of us did not get the other one. So if you are true, let me know so that we can move on to the next item. Can I clean the board? Hello? Are you still there?
Yes, please.
Yes, sir. We are still here. You can, sir.
Okay. Now we'll take the third question for today. I dictate. The third question says, the table below shows the distribution. The table below shows the distribution of marks. Distribution of marks obtained. Distribution of marks obtained by 100 students in a text. The table below shows the distribution of marks obtained by 100 students in a text. There is a line here. Here is marks, M-A-R-K, and here is our frequency. And because it's a group, this is 10 to 19. Next one is 30 to 39. I said the max, the first group is 10 to 19, and the frequency is 1. The next one is 20 to 29, and the frequency is 3. The other one is 30 to 39, the frequency is 7. Are you there?
Yes, sir.
Have you written this? So after 30 to 39, the next thing is 40 to 49. 40 to 49, frequency is 20. 40 to 49, frequency is 20. The next one, the next group is 50 to 59, and the frequency is 30. Frequency is 30. The next one is 60 to 69. 60 to 69. The frequency is 22. 22. The next group is 70 to 79. 70 to 79. The frequency is 10. 10. The next group, 80 to 89. 80 to 89. The frequency is 5. Frequency is 5. The final group, 90 to 99. 90 to 99. The frequency is 2 whole number 2. The question now says, next line, using 54.5. Using 54.5 as assuming using 54.5 as assuming, comma, calculate Roman figure 1, mean mark. Roman figure 2, variance. Roman figure 2, variance. Roman figure 3, standard deviation. Roman figure 4, interquartile. Interquartile range. Interquartile range. That's Roman figure 4. Finally, Roman figure 5, semi interquartile range. Semi interquartile range. There is interquartile range. There is semi interquartile range. So that's how to handle this kind of problem. But let's see how we can do it. Are they ready?
Good afternoon, Gabriel.
Yes, sir.
Good afternoon. You're welcome. Michael, how you doing?
Thank you, sir. Well done, sir.
You're just joining, Abby?
I joined like 10 minutes ago.
Okay.
Yeah, thank you, sir.
Okay,
please, I want that range back from 30 to 39, 40 to 49.
Okay. Oh, yeah, let's take 30 to 39, 7, Abby?
7, yes, sir.
40 to 49, 20.
40 to 49, 20. Okay, sir.
50 to 59, 30,
yes,
30.
30, okay.
60 to 69, 22.
22.
70 to, is that all?
Okay, go ahead, sir. 70 to 79.
No. 70 to 79, 10.
10. Okay.
80 to 89, 5.
5. Okay.
Then 90 to 99, which is the last one, 2.
Thank you, sir.
So now I want to find the mean, first of all, because the question wants us to find mean. And all these mean, all of them are based on assumed words mean. And with that information, we can go this way. We can go this way. We have this. We have another column. Have another one. Have another one. So in a simple language, let me even shift it to this other side. Okay, starting from here, this way, another one, that one, that one. We'll go this way. Here's our X. No, sorry, these are max. M here, max. We're talking about 10 to 19, 20 to 29, 30 to 39, 40, 40 to 49, 50 to 59. Okay, let's do it this way because I believe the table may not contain at once. But this is what I want you to do. Hello, are we there?
Yes, sir.
Can you hear me?
Yeah.
So
Yes,
now draw
please.
a column. Everybody should draw a column in this note. Mark. First of all, arrange mark till the end. 10 to 19, 20 to 29, 30 to 39, till 90 to 99. If you are done, you let me know. Frequency, we all know what it is. So I arrange that one first. Frequency 1, 3, 7, 20, 30, 22, 10, 5, 7. When you're done with that, you let me know. So we'll now start the other column and do it together. We'll be doing it together practically. So just arrange the marks, the group from 10 to 19 to 90 to 99 with their frequency. When you do that, you let me know. Are you through with the marks and frequency? Are we all through?
Yes, sir.
Good.
Yes.
Now, the next column. In that column, you write for me mid value, MID hyphen value. Some people call it mid value, some call it midpoint, some call it a center point, whichever grammar. And in that place, I have put X. For you to get that midpoint, if you check every group, the first group there is 10 to 19. What we are going to do here is to say 10 plus 19. We are looking at the lower and the upper. The upper limit, the upper limit is 19. The lower limit is 10. We'll add the two together. 19, the 10 plus 19 divided by 2 should give us 14.5. Agreed? 20 plus 29 divided by 2 should give us 24.5. Is it accepted to all of us?
Sir?
The first,
Okay,
the first group.
Yes, sir.
Hello.
Yeah,
Can
thank
you
you.
hear me now? Okay. Well, can you hear me now?
Yes, I can hear you, sir.
Okay. I said the first group is 10 to 19. So 10 plus 19 divided by 2 should give us 14.5. Is it correct with your own calculation? Please press your calculator and confirm. 10, which is
Yes.
the lower limit, plus 19, which is the upper limit, added together, divided by 2, as if you are finding the mean. 14.5. Agreed?
Yes, sir.
Yeah.
Good.
Yes.
Just a quick question. What did you put on top of the colon? That on top of the X. What's that? It's not clear.
That X is mid value. The VDS value.
Okay. Mid value.
MID
All right.
value or point, as the case may be. So mid value, the first one 14.5. 20 plus 29 divided by 2 is 24.5. Agree?
Yes.
Yes, sir.
The next one is 30 plus 39 divided by 2. That should be 34.5. Accepted?
Yes, sir. Accepted.
If you have done it like this in examination, you don't need to give yourself stress again. If this comes out in examination and you have all this, all you just need to do, because it's equal interval between 10 and 19 and 20 to 29, they are equal. So because they are equal, you can do what I want to do now. An examination question will always give you equal interval. If you check, the first group is 14.5. The next is 24.5. So if the first group is 14.5 and the second is 24.5, if you check, the difference is 10, 10, 10, 10, Abi? Hello? The difference between the first group and second and third is 10, 10 all around, Abi?
Yes, sir.
Yes,
so
sir.
Keep on adding 10 and be writing your answer. The next one will be 44.5. Next one is 54.5. Oh yeah, running like that till the last group, which is 90 to 99. Just 34.5, 44.5, 54.5, 64.5, 74.5, 84.5, and like that till 94.5. I hope that must have been recorded by all, or you have understood what to do. Is that column clear?
It's clear, sir.
Very good. Then it is clear. If you check the question with the copy, the question says use 54.5 as assuming, and these are 54.5. Abi, in your table, 54.5 is now our assumed mean. Our next column, the next column is for us to calculate deviation. And our deviation will be x minus a. And you are aware that our a is 54.5. Is it clear?
Yes, sir.
Our first group, the value for midpoint, because what you're using is the midpoint.
Yes.
Our marks are no more important. After we must have gotten the mid value of midpoint, that group marks is no more important in our calculation. What is important now is the mid value. The first mid value is 14.5, which is the x. So 14.5 minus 54.5. Result will be minus 40. They agree? The next one will be minus 30. Another one will be minus 20. That means 44.5 minus 54.5, it will be minus 10. 54.5 minus 54.5 is 0. Are they following?
Yes, please.
Yes, sir.
After the zero,
Following, sir.
after the zero, the next one will be 10, 20, 30, 40. After the 0, the next group will be 10, 20, 30, 40, like that. Has that been written?
Yes, sir.
Good.
Yes, sir.
Good. So that column is done. The next thing we are going to do is another column, which will be D square. This is our D. That one is our D square. And you know that our D was minus 40. When we start squaring, remember, the minus sign will disappear because minus times minus will always be plus. And the next one will be 1,600, 40, 40, 1,600, 30, 30 is 900, 900, this one, 400, the next one, 100, and this one is 0. I hope I'm communicating. So that means to say that after the 0, the next one will be 100, 400, 900, 1,600. Just reverse of the beginning. After the 0, we have 100, 400, 900, 1,006. I hope that is understood. The values are already on the board. We are taking it backwards. After 0, we have 1, 400, 900, and 16. So that is the D square column. And we're trying to approach FD. The FD column. Frequency times deviation. Our F column, which you know, as 1, 3, 7, 20, 30, 22, 10, 5, 2. We're going to multiply them the way we have been doing. The first frequency is 1. 1 times minus 40 is minus 40. The second frequency is 3. 3 times minus 30 will give us minus 90. The next one will be 7 times minus 20. I'll get minus 140. The next one will be frequency of minus 10. It will be minus 200. The next frequency is that one that has 0. So it will also be 0. After this 0, the next one, as usual, will be 220, 200, 150, 80. For that column, remember the column is, that means 1, 3, which I believe you still have, 7, then 20, then 30. This is where my table stop. Your own, and now you continue. So what I did was F times D. 1 times minus 40 is minus 40. 3 times minus 30 is minus 90. 7 times minus 20 is minus 140. 20 times minus 10 is minus 200. 30 frequency times 0 is 0. So you continue like that. After the 0, you have the next one will be 220. The one that follows should be 200. The next one is 150. And the last one, which is the group of 90 to 99, will give us 80. Any questions? And the last column here will be FD. FD squared, this particular column. The last column is FD squared. FD squared. Take note, the last column will be FD squared. And that means I'm going to use frequency to multiply D squared. And we're going to have the first one, 1/6. The second one, 2/7. The next one, 2/8. Two eights, 2/8. The next one is 2000. Another one is 0 as usual. So that last column is FD raised to power 2. That means the frequency column is multiplying the D square column to give us the last column on this board, FD squared. And the values are 1/6 for the first group, 2/7 for the second group, third group is 2/8, fourth is 2000, fifth is 0, the sixth group is 2200, the next one is 4000, the one that followed is 4005, and the last group of 90 to 99 is 3200. Any questions? Are you still there?
Yeah, we're here, sir. I will just, why not just write the, on top of the column, the FD squared. I think it will be clearer to have it written on top of that column as FD squared.
That's what I'm trying to do something here, but it's not agreeing. And that's why I'm trying to call it for it. Because after the FD, the next thing is FD square. It couldn't come up the way I want it. So FD square, always towards the end of the board, sometimes they do affect. Either maybe I have exceeded the line.
All right.
Sir.
So, but just remember, yes, go ahead.
For the marks under 70 to 79, the FD square.
70 to 79.
Yes,
is 4,000.
FD square. 4,000.
4,000. Yes. 4,000. 80 to 89. 45.
Okay, all right, sir. I've seen the mistake.
And remember, what we are doing is that we use the frequency value to multiply the D square value to give us FD square, in case you have forgotten. Another question now. Are we now on the same page? So if we're all on the same page, our frequency column, the total is 100. Draw a line and close it is 100, like this. The total for frequency that you have, if you add 1, 3, 7, 20, 30, 22, 10, 5, 2, the result will be 20. And you remember in the beginning of the question, we were made to understand that there were 100 students. So the total frequency is 100. And the FD column, the total is 180, 180, 180, 180 for FD column. The last column, which is FD square, should give us 23,000. 23,000. Do not forget, frequency total is 100. FD column is 180, 180. The last column, which is FD squared, is 23,000, 2330. Any questions? Are we there?
Yes, sir. We are with you, sir.
So we can clean the board now so that we can get the values as we want it. Now we have gotten the table. So Roman figure 1 or A, whichever one, our mean mark should be equal to the assumed mean, which is A, plus summation of FD over summation of F. That's to find mean using an assuming approach. The question gives us assumed mean to be 54.5 plus the column FD is 180. The total number of students in that question is 100. So we're having here 54.5 plus 1.8. 1.8. And our mean from all indication is 56.3. So that is the answer to Roman figure 1. Roman figure 1, mean mark. Calculating mean using assumed mean approach. Any questions? I hope it's clear.
Yes, I did summation FD. You said it's 180. I'm having 170.
Okay. Let's check now. Maybe the first one you got minus 40, Abby?
Yes.
Minus 90, minus
Yes.
140, minus 200,
Yes.
0, 220,
Yes.
200.
210. 210.
No.
After 0, it should be 210.
Wait now,
It's
wait.
200,
Take note, sir. Just take note. That group 70 to 79, are you there?
Yes.
The frequency is 10, agreed?
Yes.
Then deviation was 20, agree?
Yes.
10 times 20.
200. The frequency,
Should be 200. That's what
the
I'm saying.
frequency
Not
of
210.
the frequency of 60 to 69.
Okay. Frequency of 60 to 69 is 22. Are you there?
Oh, it's 22, not 20. Oh, okay. Sorry.
No,
I wrote.
22.
Oh, it's
That's
22.
another time. It's
Okay,
just
I've
error.
seen where I made the mistake. Okay. Sorry, sir. I've seen it.
No,
I
no,
wrote 21.
no problem. So it's okay.
Yeah.
What matters is we're all learning. No problem. Now, that one has gone. That is dictation. So, but this is how to do it. And that's the answer to that question. So we're moving on to variance, if you are through with this board. Can I clean the board? Okay. Roman figure 2. Variance is summation of FD square over summation of F, summation of FD over summation of F, everything raised to the power of 2. Result, FD square is 23,000 over 100. 23,000 over 100 minus 180 all over 100, all raised to the power of 2. And we can see for ourselves 250, 250, I believe, 230, yes, 230. 230, 230 minus 1.8 squared, that will be 3.24. And from all indication, when we draw our subtraction, we are getting 226.76. So that's the value for variance. Is that clear? This is Roman figure 4. Standard deviation is the square root of variance. And that means the square root of 226.76. So our standard deviation to find the square root should give us 15.06. 15.06. So that is a solution to Roman figure 1, 2, 3. We'll now move on to Roman figure 4 and 5. So that's all for variance, and that's all for standard deviation. Any questions? Are you people still there?
Yes, we are here.
We are here, sir.
Good. So you can see the way I manage the board. Variance is 226.76. Standard deviation is the square root of variance, which is 15.06. So that one is done. We are going to now look at the interquartile range. You know, when you talk about range, range is always the difference between the bigger and the smaller. But when you talk about quantiles, the highest quartile is 3. Quartile 3, and the lowest is 1. So the difference between quartile 3 and quartile 1 will be our interquartile range. But if the question did not give you all this range, you must look for it from this particular information that we're going through now, as if you are finding a median mode in a group data. So we're going to see how to handle those two. Can I clean the board?
Mm-hmm.
Good. So the next thing is Roman figure 4. That Roman figure 4 says interquartile. Quartile means 1/4. Quartile range. The formula we're made to understand is upper quartile minus lower quartile. And this quartile is Q3. And this one is Q1. And in this question, they have not given us Q1 and they did not give us Q3. So our knowledge of calculation, our knowledge applied in calculating median of group data is what we're going to use. If you have not forgotten, when we're looking for median, we normally write L1 and so on and so forth formula. So we apply it. So we're going to calculate Q3 first. We're going to calculate Q1. And if we get that, we do the subtraction. The second one, which is the fifth question, which says semi, we just divide by 2, and that will get our answer to this particular problem. So because that semi means there will be division of 2. So I won't put this one down, I believe. We're going to look for Q3. There is a formula to that effect. We're going to look for Q1. There's also a formula to that effect. So I'll go look at that, and the results will be found. In this case, we have Q3, quarter 3. Formula is LQ3 plus 3, because it's always a quarter. That 3 you are seeing will be 3/4. Because when we talk about quarter, it's quarter. And quarter is always 1/4. But because this one is Q3, so it will be 3/4. So in this case, we have 3/4 n minus 3/4 n minus summation of FB all over frequency of Q3 times class interval. Look at the board. We're not giving quarter 3. Assuming it is cumulative frequency now, we can also find quarter 3, because quarter 3 is always 75 percentile. 75 percentile means 75/100 times whatsoever. That's the same thing as quarter 3. And remember, Q3 means 3/4. And 3/4 times 100 is something as 75%. So if it is Q2, Q2 will now be median, which is the middle. So it's going to also be n/2. So it will now be 2/4. 2/4 is half, so it becomes n/2. That place I wrote 3n/4 will become 1/2, which is n/2. But lower, the L there means lower class boundary as it relates to quarter 3. N, we all know n. That may do summation of FB. Summation means summation of all the frequencies before the quarter 3 frequency. Summation of FB means addition of all the frequencies before Q3 frequency. The down one is a frequency of quarter 3. And why the C you are seeing there is what we did before, but C here is length of the class interval. Length of the class interval. So to solve this question, I need to find the QR position. Any questions so far with the formula?
Yes.
Please do.
Hello, sir.
Eh?
From the formula, what does the B mean? please.
Before. That summation means summation of F is frequency. Summation of frequencies before the Q3 frequency. You know, Q3 is the quantity 3.
All right,
you
thank
may
you.
have, okay, good. Another question?
Hello, sir. The 3n over what? We can't see it's shaded.
Okay, 3n over 4.
Over 4. Okay,
Yeah,
okay.
3 over 4.
Okay, thank you, sir.
Because quarter means 1 over 4, just by 4. Because this one is Q3, 3 over 4. If it's Q1, it's 1 over 4, like that. Is that okay? Everything is settled. So all we're looking at now is to find that group. One of the ways to find a group is to look for Q3 position. And the position is 3n over 4, which will be 3 times 100 over 4. The position of the Q3 is the 75th position. That means the position for us to ascertain the group that fits quantity 3 is to get the 75th number. How do I arrive at that? Very simple. Our group is from 10 to 19 down to 90 to 99. And there is a frequency according to this question. And we are made to understand that the frequency is 100, I mean, 100. I'm going to count from beginning. 1 plus 3 plus 7 plus 20 plus 30 plus 22. If somebody can add it for me, let me know. Okay, add for me. Okay, that's it. 1 plus 3 is 4. 4 plus 7 is 11. 11 plus 50 is 61. That means the frequency that is 30. That frequency 30. The frequency that is 30 that gives us the 61st position, which is the group that is 50 to 59. To get 75th, we have to move to the 22 frequency. Is it clear?
Sorry, sir.
Go ahead.
Sorry, sir. How did we get n to be 100? I thought n was the, I mean, that 100 is the summation of the frequency. Is that the same thing as n?
N represents the total number now, frequency. That's the meaning of n. The n you are seeing, this n, is the same thing as this.
Okay, all right.
Good. So now I want to get the 75th position. It is the 75th position that will be our Q3. And that 75th position falls under the frequency 22. And the group is 60 to 69. Is that clear?
Yes, that's clear, sir.
Good. So that means we have seen Q3 class, which is 60 to 69. Q3 frequency is 22. From 60 to 69, which you know is class limit, we'll change it from class limit to class boundary because our formula does not work with limits. It works with boundaries. So the Q3 class limit is 60 to 69. The Q3 class boundaries is 59.5 to 69.5. I will explain, but I can clean this. Now, the Q3 class limits is 60 to 69. That is settled. Now, the Q3 class boundaries. For you to change from class limit to class boundary, you need to subtract, because this is a whole number. This is a whole number. Because it's a whole number, you subtract 0.5, 0.5 from the lower class limit and add 0.5 to the upper class limit, because this is a whole number. If this our class is in decimal, if it's 1 decimal point, let's say this thing was 60.1 and 69.2, we're going to subtract 0.05. 2 decimals is what we're subtracting for us to change it from class limit to class boundary. But this is a whole number, we'll subtract just 1 decimal point. So here will be 59.5 to 69.5. Any questions so far? So now, our lower class boundary as it relates to quantile 3 is 59.5. Our quantile 3 frequency is 22. And if you check what we have done, the Q3 frequency is 22. The frequencies before Q3 are 1, 3, 7, 20, and 30. In a simple language, frequency of Q3 is 22. That is settled. Another one, summation of FB, that's FB will be 1 plus 3 plus 7 plus 20 plus 30, which is which should be 61. Any question? All the formulas have been defined. LQ3 is 59.5. That is a lower class boundary of quantile 3 is 59.5. Frequency of quantile 3 is 22. The frequencies before 22 are 1 plus 3 plus 7 plus 20 plus 30, and that is 61. Another one, our class C, our C is 10. How do I arrive at 10? It means 69.5 minus 59.5. The interval, the length is 10. So as far as the formula is concerned, everything has been clearly stated. What we're going to do now is what they call substitution, so that we can get Q3. Any questions? Are you still there? Have you seen the Q3?
Yeah. We are here, sir.
We have seen it, but okay.
But
that C is class interval.
yes, class interval. That means between 69.5 and 59.5, the difference is 10, Abi?
Yes.
So that's the class length or the interval. Settled. I hope there's no part of the formula we have not calculated. We have seen the lower class boundary of Q3 as 59.5. In the formula, we know N, which is 100. Summation of FB is 61, it has been calculated. C is 10. All we need to do now is substitution. Can I clean the board?
Yes.
Now, our Q3 will be equal to 59.5 plus our 3n over 4 should be 75. We have calculated that.
Yes.
Minus 61 all over 22 into 10. Is it okay?
Yes.
Everything has been stated. So it's just substitution and pressing our calculator where necessary. 75 minus 61 will give us 14
Over
22 into 10. And from all indication, I can see 59.5 plus 140 divided by 22. Somebody must have calculated everything. 140 divided by 22 should give us a value which is
6.36.
Good, to give us 65.9. That is the solution to our Q3. Now we have gotten Q3. It's just to follow that same method and get Q1 so that we can apply interquartile range and semi-interquartile range. I hope it's not that difficult. So the next thing, the same approach we're applying, but the formula will just be small adjustment. It's only one thing we just remove. The formula is still the same thing. Remember Q1, it means it's 1. It means 1 over 4. When it's Q3, it means it's 3 over 4. If there's even Q5, but at least it's quarter. So you can't go more than 5. You can't go more than 3. Because if you go to 4, it means 4 over 4, which is 1. So it's no more relevant. So when we talk about quarter, we can only have 1, we have 3, we can have 2, and that 2 becomes a median. So the quarters available is quarter 3 and 1. Quarter 2 is median. If you are asked to find quarter 2, it's the same thing as finding median of a group data. So with this now, we move. I hope I can take it up. Okay. So quarter 1, Q1 will be LQ1 plus N over 4 into the same thing, summation of FB, the same approach, all over F, Q1, then C. All we need to do here is to find Q1 position. And to find this position will be N over 4. And our N is 100 divided by 4. And this should be 25th position. That means the 25th position will be our Q1 class limit. And to get 25, I can see for myself that the one that will fall into 25 should be 40 to 49, because 1 plus 3 plus 4 is 11. 30 to 39 falls to the 11th position. To get the 25th position, we must enter 20, which is 40 to 49. So our Q1 class limit is 40 to 49. Our Q1 frequency is 20. So we can say for ourselves, Q1 class limits is 40 to 49. So we also try to change it the way we have done. So we'll now turn to 39.5 to 49.5. And we can see for ourselves FQ1 will now be 20. As for this one, in that our formula, FQ1 will be 20. Our Q1 class limit is 40 to 49. Any questions? Are they still there?
Yes, sir, we are still here, sir.
Okay, good. Now, I can clean this board. I have found FQ1, 20. Q class limits, I've gotten that, so I'm going to change it to boundaries. So I'm going to write Q1 class boundaries by subtracting. So that one will be 39.5 to 49.5. So another thing to look at, summation of FB. Remember that the Q1 frequency was 20. So this one will be 1 plus 3 plus 7. Result will be 11. Which other one again? Class length is 49.5 minus 39.5. If you check, it's still 10, like we did before. Everything about the formula is intact. So Q1, the lower class boundary, okay, lower, let me put it here, lower class boundary for Q1 is 39.5. Everything has been stated. Lower class boundary Q1 is 39.5. N we know is N over 4. Already we have calculated as 25. Class length of the class is 10. Any questions? Remember that the Q1 frequency is 20. We added the frequency before 20, and the result became 11. Any questions? Who is not clear?
Yeah, okay, sir.
Good. Now to quickly get that level, our Q1 will be equal to 39.5 plus, this one is 25, N over 4, 100 over 4, 25, minus 11 that we just got, minus 11, And this one is just 20, and this is 10. So we have 39.5 plus, this should be 14. Yes, 14 over 20 multiplied by 10. So we're having here 39.5, 1/4, 110 over 20. As usual, 140 divided by 20 is 7. And 7 plus 39.5 is 6. So everything is taken care of. So now that we have gotten Q3, we have gotten Q1, we can now solve Roman figure 7, Roman figure 3, 4, which is interquartile range before doing semi-interquartile. So the problem is easier. Can I clear now? Or are you still copying? Or you finish, you let me know. Can I clear?
Yes, sir, please. We're done. We're done.
Okay, good. Finally, with this one, Roman figure 4, interquartile range is equal to Q3 minus Q1. And our Q3 is 65.9 minus our Q1, 46.5. And the result is 19.4. Roman figure 5, which says is semi-interquartile range will be equal to Q3 minus Q1 divided by 2. So which means the result to that one is 19.4 divided by 2. So it's going to be 19.4 divided by 2. And that will give us 9.7. So that is it. Our semi-interquartile range will be Q3 minus Q1 all over 2. And that will be 19.4 that we just got from Q3 minus Q1 divided by 2. And that will give us 19.7. Any questions? Or is not clear? Any questions?
All right, sir. Thank you very much, sir. My question is, can you please give like an application of this, where this can be applied? Because I see it's a lot of computation, and I want to know where it can be applied, for practical use.
Okay, for normally this one we're doing, in this particular course, there is hypothesis.
Yes.
There is, yes, there's hypothesis. And what this one is giving us is background on how to calculate, especially when we're doing a binomial probability distribution, which involve binomial balloon and not rest of it, how the mean will come and we're able to analyze. But like this one is just a kind of foundation to give us the range of a particular thing. Maybe I want to see a range. What is the range between a particular group of people? Then I do this to interpret that. But more or less, this one is a foundation to that one we are going to actually enter. That's what I saw in that first outline statistics there. Because after this, now we're now going to regression, correlation, and see how it can be interpreted. When is a positive or is negative, and the rest of it. But this one is more of a foundation. But to calculate mean, which is average, just to know the average of that particular population. What is your background on simple calculation to lead us to where we are?
All right, sir. Thank you, sir.
You're welcome. So we'll be taking another one, but that one will not take us time. Maybe from there, let's see whether we can just finish that one. So the next time we'll come, we'll practice the past question. On this one, we are concluding today. These statistics. I know there's another one which I believe, that one we can just look at it together. That is a representation of data. How to draw a pie chart. I hope we all know how to do that one. Hello?
Hello, sir. Yes, we know how to draw pie charts.
Yeah, so at least I don't want to bother myself so much on that. How to draw pie chart, bar chart, histogram. One should know that bar chart, when you are drawing it, the space in between must be the same. You use a ruler to measure it to make sure the spaces in between each bar is the same. And the length of the bar, the breadth of the bar, the width must be the same also. Those are the conditions to look at. Pie chart is not a problem. When the circle is drawn, we know circle means 360. So one can calculate that one easily and draw it. But
Mr. V.
every other thing we see the past question.
Mr. V.
Yes.
Some of us don't know how to draw pie chart and bar chart. So maybe when you come next Sunday, physically you show us.
The pastor, let me just inform you, so that you can have it in mind. Next week, Sunday.
Am I speaking your mind?
No,
Yes,
Mr. We'll do it on the board. Fine. But the fact remains that next week, Sunday, we'll also do it like this, because by next week, Sunday, I will not be in Lagos. Are you following? Is Mr. Gibson there?
Yes, I'm here.
I said by next week, Sunday, I won't be in Lagos. So definitely the class will hold like this. But the other one, I will come and draw it for them if that is they need that drawing. But like I said, we'll finish this topic today apart from that drawing. When we'll come, we'll do past question and other things too next week. But when I come, we can show them the drawing and how to also answer question when there is no drawing. We'll look at that because there's call to duty. I have to be outside to have a meeting with some people. Okay? Do other things. But meanwhile, definitely you will understand. But let's quickly take this one before we know what we are going to do to conclude it. Are you ready?
Yes, sir, we are ready.
Cumulative frequency distribution. That's the last part of this drawing before those pie chart and whatever. Cumulative frequency distribution. Cumulative frequency distribution. And O give. Look at the board though. The O and the G are far from each other, showing that O is a load, give is a load. Is that okay? Cumulative frequency distribution and O give. I try to explain. An O give curve, an O give curve is a line graph. An O give curve is a line, L-I-N-E, line graph that represents the cumulative frequency, that represents the cumulative frequency. This one is simply telling you that cumulative frequency is different from O-give. The O-give is the drawing, the graph that will draw. The frequency is our calculation to help us draw the graph. Full stop. A curve that represents the cumulative frequency distribution, a curve that represents the cumulative frequency distribution of grouped data, a curve that represents the cumulative frequency distribution of group data is called an O-give, or cumulative frequency curve, an O-give or cumulative frequency curve. Are we there?
Yes, sir, we are here, sir.
So we'll take a question to analyze that. The graph will tell you what to do, and you, or when we come to the board, we'll draw it. But let's just do the calculation part. The data below shows the weights. The data below shows the weights to the nearest kilogram. The data below shows the weights to the nearest kilogram of a group of 50 athletes. Group of 50 athletes. You now write 74, 84 like this, 65, 86, 71, 75, 66, I mean 74, 84, 65, 86, 71, 75, 66, 82, 82. It should be on a straight line, though. 82, 64, then finally 61. The first row are 74, 84, 65, 86, 71, 75, 66, 82, 64, 61. Are we through with that first row?
Yes, sir.
Yes, sir. Yes, sir.
The second row should be under each of the number. So the second row under 74, 78, 79, 78, 79, 81, 69, 88, 67, 82, 73, 66, 78. The third row.
Sorry, sir. Can you repeat the second row? Thank
okay,
you, sir.
78, 79, 81, 69, 88, 67, 82, 73, 66, and 78. Are you there now?
Hello, sir.
Yes?
Yes,
Okay,
sir.
they are still running. Okay, they are still running statistics class.
Yes.
Okay.
Anybody?
Okay.
Oh,
I've already joined. Once they are through with statistics, I will join. Yeah,
okay.
I think I will start. I've already joined.
Okay, which one are you? Which one are you for? Okay. Don't worry, we'll soon close for this one. The next row, the third row now, 60. The third row is 60, 65, 68, 61, 74, 69, 73, 77, 62, 75. Hello?
Yeah, with you, sir.
Okay, the fourth row, 64, 75, 71, 62, 87, 73, 67, 72, 64, 68. The fifth row, which is the last one.
Sorry,
The
sir.
fifth
First
row.
item. Sorry, sir.
Yeah.
That fourth row, sir. What's the first number, sir?
64.
Thank you. Thank you, sir.
So the last row, which is the fifth row, 82, 80, 70, 63, 71, 74, 67, 71, 85, finally 68. Everything must be 15 number. Question A. Question A. Construct. Roman figure 1. A group frequency table. Construct Roman figure 1. A group frequency table with the class interval. With the class interval 60 to 64, comma, 60 to 64, comma, 65 to 69, comma, 70 to 74, comma, etc. 60 to 64, 65 to 69, 70 to 74, etc. Roman figure 2 of question A cumulative frequency table. A cumulative frequency table for the group distribution. A group frequency table for the group distribution. Question B, that was the end of A. Then B, draw the cumulative frequency curve. Bracket open and close, O give. Draw the cumulative frequency curve. Bracket open and close, O give. For the group distribution. C, draw the cumulative frequency curve for the group distribution. Are you there? C, finalist. C, use your O-give. Use your O-give to estimate, correct, to the nearest kilogram. Use your O-give to estimate, correct to the nearest kilogram. The Roman figure 1, median. Roman figure 2, upper quantile. That is a Q3. Upper quantile. Roman figure 3, lower quantile, which is Q1. Roman figure 4, 30th percentile. 30th percentile. Full stop. So we only just do 2 because the other one involved drawing. You can try that, or when we'll come back, we'll do that. But quickly to respond so that we'll call it
So please, that's B, the Roman figure 2.
Roman figure 1,
median.
Yeah. Roman figure 1, median. Roman figure 2, upper quartile. Is that the one?
Okay, yes, sir.
3, lower quartile. And 4, 30th percentile. So let's see how that was. We won't waste time on this one without wasting much of our time. We have this. This will be class. We call this one class interval. Class interval. Class interval. This one will be our tally for us to calculate, and this will be our frequency. So the question has agreed that we should label 60 to 64, 65 to 69, 70 to 74, 75 to 79. And from all indication, and while we are naming this thing, we are checking what we are giving, whether there's any number within that range. Then 85 to 89. I hope that was the last. There's no other value up to 90. So our class, based on what we are given, we'll look at it from 60 to where it is there. The highest is 8 something. So there's no 90. So 60 to 64, 65 to 69, 70 to 74, 75 to 79, 80 to 84, 85 to 89. And if we check, taking our time to look at the figures between 60 and 69, if you check, we're going to have 1, 2, 3, then 5, then another one. If you check, we don't have time here. Take your time to check, counting the numbers within that level. You'll see something of this nature. That crossing makes it 5. Every crossing is 5. And there's another 2 remaining, making 12. The next one is also like that. If you take your time, a cross there is 5. Another cross is also 5. After 4, you cross it with the 5th one, and that is also 12. The next one is also similar. There's a 5. Yes, go ahead.
Bread at woman I'm saying at malt.
Okay, this is 7.
Rio, and it's 4:30. Okay, once you get not busy.
You have
okay, one is office pastor. Oh yeah.
Finally,
I'm saying in a class. The class will end by 6.
So this is it. And the last one there will stop one more, then we'll go. So the last one is cumulative, just to add things together. I don't want to join it with this, but what you are seeing on the board, this one is question A, Roman figure 1, which says you should construct a class interval stuff. And the second one says you should do a cumulative table for group distribution, which I'm going to do now. Copy this. So take your time. If you look at numbers, the first row, how many 60 to 64 is there? The second row, how many 65 to 69 is there? And with that, let me just do that one. No, we're eating into the time of the next person, but let's just do that one. Can I clean this?
Yes, sir, you can.
Good. So we take the table again. The table is still the same. Table is still the same. But this time around, we're having the class interval also there. This frequency here. And this is the cumulative frequency. So we're still having 60 to 64. Now remember our frequency then was 9. There will also be 9. 65 to 70 to 69. The frequency then was 12. So it's going to be 9 plus 12 to give us the cumulative frequency as 21. Then it's 70 to 74. The frequency we got was also 12. We're adding, that's why it's called cumulative. That means we're adding things together. 21 plus 12. The real cumulative figure will be 33. 33. And 75 to 79. The frequency we got that time was 7. So it's going to be 33 plus 7 to give us the frequency, cumulative frequency as 40 for that particular group. 80 to 84. Our frequency that time, was 6. Cumulative will be 40 plus 6 to give us 46. And finally, 85 to 89. 85 to 89. The frequency at that time was 4. And that confirms to us, according to the question, there are 50 outlets. And when we add all, the last one should give us 50. So this one is alphabet A, Roman figure 2. The other one I did was alphabet A, Roman figure 1. Any questions? Any queries?
Sorry,
Any-
sorry. Hello, sir.
Go ahead.
Sorry to take you back, but I
go
want to
ahead.
know on line 1 of the data or data distribution. I want to know what is in column 6. Is it 25 or 75?
Okay, the past one, Abi, not this one.
No, this particular one. You know that you read out all the figures for us. The first row, the second row, and third row, and fifth row. I'm talking about the fourth row.
Oh, fourth row.
Number 1 row. First row. Number
Okay,
1.
first row. First
Yes.
row is 74,
Yes.
84, 65,
Yes.
86, 71, 75, 66,
That's
82.
right, sir.
Is it okay?
Yes, sir. I
Good.
think I got the 75 as 25.
Okay. So, any other question on that note? Any other questions? So, if there's no questions, I believe that's all I can possibly take for today. By the time we'll continue some other time, we'll look at some past questions that relate to what we have solved, especially the statistics alone, so that we'll try that before we take any questions? Question?
Okay, thank you very much.
Good.
Thank you. Thank you, Mr. Vincent.
Thank you very much. Bye.
Yeah.